Everyone gone through the video that I have sent? Yes. So it was what we have studied in last class, right everyone? I hope all of you understood. Kushagra, that's why I have given the video, right? Everything is there. In last class also, okay. In last class also, I told you that videos is already there. It's already on the YouTube channel, okay. Because I have taught resolution vectors like 3 to 4 times. In last class also, I taught resolution vectors. The video that I sent like this 30-40 minutes before, in that also I've taught how to resolve vector, okay. So please watch that video. Okay. Okay, everyone. Right, so everyone is here, I guess. Most of you are here. Okay. So the concept that we have studied in last class was your basics of force equation. Okay. Basics of force equation. Now, when you talk about resolution of vector, what is it? It is nothing. It is just breaking down your vectors into components. That's it, right? Resolving a vector means breaking down your vector in its components. So basically, hypotenuse is given, you have to find perpendicular and base. As simple as that. As simple as that. Nothing else you have to do, right? So obviously, if hypotenuse is there, then base is hypotenuse cos theta, and perpendicular is hypotenuse sin theta. Yes or no? Tell me. Yes or no? Right? And in same way, if vector is given, making angle theta with x-axis, making an angle theta with x-axis, so I can say that the x component will be the base of right angle triangle, right? And y component will be the perpendicular of right angle triangle. So I can say that x component is your vector cos theta, magnitude of vector into cos theta, I cap, plus magnitude of vector into sin theta into j cap. Right, everyone? Okay, that's it. Okay, now in last class we studied about different cases. Okay, we talked about tension force, we talked about normal force. Okay, right? And we started constraint motion. I hope all of you remember that. Pulley problem, case 3. Okay, so we will continue that case. Okay. Okay, I'm clearly audible. Yes. Okay, so let's start today's class. Most of you have joined. Okay, so let's start today's class. We will start with pulley and constraint motion. Okay. Motion. So what's the meaning of constraint motion? First of all, you have to know what's the meaning of constraint motion. Now just think of example. Suppose I'm having this mass m1. Okay. Now it is tied up with another mass m2. Just imagine m2. Now if you're pulling this mass m2 with force F, what will happen? Tell me. Will m1 move? Yes or no? As simple as that. Will m1 move? Yes? Agree? Right? It's basic common sense. M1 will move. But obviously you're applying force on M2, right? Then how come M1 is moving? Because it is attached to M2, right? There's a constraint. Okay. Right? There's a constraint that M2 is attached with M1. So if M2 will move, M1 has to be moved. Has to move, right? Okay, because of tension of y. Yes, exactly. So I can say that this type of motion is called as constraint motion. Okay, right? So obviously constraint motion, when you talk about constraint motion, there's always more than one object. Yes or no, right? More than one object. Okay, so this is the simplest problem of constraint motion. Okay, now when you talk about this, right? Suppose we have a pulley. This example that I gave in last class. right? So we have mass m1 and m2. This is also a case of constraint motion, right? Got it? So I hope all of you got the idea. What is the meaning of constraint motion? Okay, now how to solve a problem when we have constraint motion. So first thing that we have to do, free body diagram. Agree? So just take this case. Just take this case. Case 1. Okay. Just take this case, case 1. Can you draw the free body diagram of both M1 and M2? Right? So on M2, we have force in this direction, which is F. We have force in backward direction, which is tension due to this wire. Yes or no? Yes or no? Yes, very good. Now, on M1, we have tension in this direction because I have told you that if wire is same, then tension is also same. Yes or no? If wire is same, then tension is also same. Okay? Right. Okay. So this is your first step, step 1. Step 1. Everyone is clear with step 1? Tell me. Everyone is clear with step 1? Okay, very good. Now what was step 2? Tell me, what was step 2? Step 2. What was step 2? Yes, equation. Very good. Okay. So second step was writing the equation. So since we have two masses, we will write two equation. Okay. So for mass M2, right? Write it down. For M2. Now what are the forces acting on M2? Tell me. This F and this T, yes or no? Now, when we talk about writing an equation, you have to write Newton's second law of motion. You have to use Newton's second law of motion, which is net sum of all the forces is equal to mass into acceleration. So F minus T is equal to M2 into, suppose it is A2, right? Acceleration of this M2 object is A2. Yes or no? Tell me. Yes or no? Why I have written F minus T? Because T is tension, right? Okay. The object will move because of force F. It is not moving because of this tension. Yes or no? So obviously F should be greater than tension. Logical? Agree? Everyone agree on this? Right? So this is for mass M2. What would be the equation for mass M1? For M1. Tell me, what would be the equation? It's fairly easy. Tell me. It is just T is equal to M1A. Okay. Because on this mass M1, right, there is only force T, right? So it is T is equal to M1 into A1. Got it? Right, everyone? Okay. Right? Now, that's the second step. I hope everyone is clear with first step and second step. First step, draw free body diagram. Second step, write the equations. Now in this case, since body is moving in x-axis, so you just have to write the equation in x-axis. As simple as that, right? Okay, but as we discussed in last class, if we have movement in both x-axis and y-axis, then you have to resolve in components and you have to write the equation in along the x-axis as well as along the y-axis, right? So you will get two equations. Okay, and that's the concept now, right? That's a concept. M1 is moving because of tension. Okay, that's the concept. M1 is moving because of this tension. Okay, because this tension is also there now. If you're pulling this mass M2, right, then because of this tension, right, M2 is being pulled backward. Got it? Right? Just imagine, physics is all about imagination. Okay, just try to have a normal scenario. Okay, right, and imagine that if you pull this mass M2, then what will happen? Okay, right? Just try to imagine, because physics is all about imagination. If you are good at imagination, if you can imagine the scenario, physics will be very easy. Okay, right? Everyone got this? Tell me. Everyone got this till this step? Right? Is there anyone who is having any problem? Because you should be very consistent and strong with your concepts. Okay, right? If you have any doubt, please ask. Jaita, Harshan, Joel, Yash, Mohit, Zaim, Neha, Pravalika, Preeti, Roshni, Santosh, Sanjana, everyone clear? Because these two concepts we have already studied last class, right? The third step which I'm going to teach is your next concept. Okay. Yes, yes, tension will always be along the string. Always be along the string. Okay. Now, just imagine. Just imagine. Okay. Yes. Yes. Right. If force is okay, you are saying if force is applied along M2, so obviously this tension will not be in action. M1 will not move, right? If you're applying force in this direction, right? Then obviously this tension will not be there, no? Right? Whenever wire is slack, tension is not there. Okay? Got it? Right? Got the concept, Mohit? Okay. So you should ask like this, right? You should ask whatever doubt you have. Okay, that's how you should study. Okay, right? Imagine and ask. Doesn't matter if it's very simple concept, just ask. Now just think about this, right? Now if you pull this mass M2 and if it moves to X distance, just imagine X distance, right? How much this mass M1 will move? Tell me, how much this mass this M1 will move? X only, right? Right? Anyone have any issue in this? So I can say that M2 will move X distance. M1 will also move X distance, right? So what would be the acceleration of M2 and M1? Obviously the acceleration of M2, suppose it is A, which is d square x by dt square, right? We know that now acceleration is equal to dv by dt, which is equal to d square x by dt square. Since it is differentiating x twice. Okay. Now m1 is also a. Got it? That is your constraint equation. Okay. So constraint equation step 3. Okay. Step 3. So constraint equation give me idea about the acceleration of objects. Okay. Got it, everyone? Tell me. Got this? Now, there are many methods to find the constraint equation, but what I'm using here is distance relationship, okay, because it is easier to understand, okay, and you can visualize this. But for this, your imagination should be very strong, okay. So I hope all of you understood this concept, right? So suppose I gave you that force applied here, I just convert this in a problem, is 50 Newton, 50 Newton. M1 is 10 kg, M2 is 5 kg. Got it? Find the acceleration of both mass M1 and M2. Okay? Try solving this. Try solving this. Yes, very good. If you put the value A1 is equal to, so A1 is equal to A and A2 is also equal to A, right? So T will be equal to, T is equal to M1 A. Now put this value here. So F minus M1 A is equal to M2A. So F is equal to M1 plus M2 into A. Yes or no? Tell me. Yes or no? So A will be F upon M1 plus M2. Right, everyone? Right? Right, everyone? Yes or no? Think about this. Okay? F divided by M1 plus M2 will give you the value of acceleration. So it will be 50 by 15. Okay, so it will be 3.33. Yes, Ankit, very good. Okay, Pragna, got it? Everyone got this? Tell me, everyone is clear with this concept? Yes, very good. Right, everyone? Okay, so can you solve this pulley problem now? Can you solve this pulley problem now? It is same as this one, right? Right? Now, just try solving this. Suppose M1 is 10 kg, M2 is 2 kg. Okay, right? Then find acceleration. Find acceleration. Okay, try solving this, everyone. I'm giving you 2 minutes. At least try. This is your question number 2. Question number 2. Try solving this. Okay. That you have to think, na Pragna, right? That you have to think, right? Because it is pulley case. So there should be gravity. The force is gravity. Yes, you can take 10. That's all you have to solve, right? That's all is needed. Okay, let's solve this. Let's solve this. So see, first of all, write the force equation and free body diagram. So on mass M2, we have a downward force which is mg and upward force which is tension, yes or no, right? And on mass M1, there's only upward force which is tension, yes or no? Tell me. Agree everyone with this force equation? Yes? Tell me. Just raise your hand. If you agree, just raise your hand. Okay, very good everyone. So for mass M2, I can say that mg minus t is equal to m1a. Now, since both of them, right, are tied together, so if mass m2 will come down by x distance, m1 will go up by x distance, yes or no? Yes or no? If m2 will come down by x distance, right, see this, if m2 is coming down by x distance, m1 will go up by x distance because the length of the wire is constant. Yes or no? Length of the wire is length of the string is constant now, right? It is not expanding. Okay. Okay, so that is the first equation for mass m1. This is m1g. For now see, okay, here we have m1g, this is m2g. For mass m2, we have t minus, this is M2, sorry, my bad. This is M2, no? M2. T minus M1G is equal to M1A. Yes or no? Tell me, yes or no? Right? Because M2 is moving down because of gravity, because of weight, but M1 is moving up because of tension. Then that you have to imagine. Agree? That you have to imagine because M2 is heavier. Common sense, right? If M2 is heavier, right, the force of Mg will be greater. Okay? Now, just equate tension or just add these two. Add these two. If you add these two, you will get what? M2G minus M1G is equal to M1 plus M2 into A. Yes or no? Just add A and B. Add AB. Add. Okay? So I can say that expression is what? M2 minus M1 into G upon M1 plus M2. Right? Now you just have to put the value. Okay? Just put the value. Got it, everyone? Right? So if you put the value, just see what is the answer. M2 is 10 minus M1 is 2 into G is 10. Whereby 10 plus 2. Right? So it is 8 into 10 by 12. So it is what? 2 by 3. So 20 by 3. 3 meter per second square. Any issues, everyone? Any issues? All if you got this, just raise your hand. If you got this, just raise your hand. If you have any doubt, ask. Abhiram, are you getting? Sujan? Suhas? Shrikar? Marnika? Sanchana? All if you're getting? Yes? Shankar? See, if you get these things now, right, your physics would be like quite interesting. Okay. If you imagine, if you can imagine, physics is easy. So you have to imagine. See, here what we have, we just have to know what is the free body diagram and how to write the equations. Okay. So shall we solve one more problem, Pulley? Yes? Shall we solve one more problem, Pulley? Okay. So I'll just make this bit difficult. Okay. Right. I'll just make this problem a bit difficult. Okay, now this is your problem. Yes, yes, you can write in fraction, no issues, right? Now this is a problem. The problem is M1 is equal to 20 kg and M2 is equal to 10 kg, right? Okay, so solve this problem. Solve this problem. Everyone solve this problem. Try to imagine and solve this problem. Take your time. It's fine if you take 5 minutes, 10 minutes. Take your time. Okay, but you should try to solve. Okay. I'll explain this after 5 minutes. I'm giving you 5 minutes. Okay, everyone? I'm giving you 5 minutes. Okay, everyone? To see, this is the free body diagram, right? On mass M1, M1G downward, tension upward. I'm considering the acceleration A1 to be downward. On mass M2, there will be two tension in upward direction because we have two wires, right? Okay. Now, write the equation. So for M1, for M1, it is M1G minus T is equal to M1 into A1. Yes or no? Right? Now in case of 4 M2, it is 2T minus M2G is equal to M2 into A2. Agree? Agree? Everyone got this equation? Everyone got this equation? Yes, very good everyone. Now, what was the third step? Tell me, what is the third step? Constraint equation, now, right? Constraint equation. You have to find the relationship between A1 and A2. Right, everyone? Now just imagine, if this M1 will go down by X distance, this M1 will go down by X distance, how much this M2 will go up? Tell me. Just imagine and tell me. Think. That's why I'm saying think. Imagination. No, no, imagine. No, it's wrong. The length of wire is fixed. Imagine, right? Just think about this. Yes, Priyanshu, right. Everyone, think again and let me know. Think. Ankit, I'm talking about distance. What's the meaning of minus x distance? Distance is never negative. Now tell me this, right? If we pull this wire by x distance, how much this pulley will go up? How much this pulley will go up? Tell me, how much this pulley will go up? How come x? If this pulley will go up, which means this wire and this wire have both have gone x distance up. Yes or no? Yes or no? If you say that this will go up by x distance, what will be the length of pulley that will be changed? Tell me, what will be the length of this rope that will change? How much this rope will change? If the pulley will go up by x distance, how much string will be changed? Tell me, right? This will go up by x, this will go up by x. The total will be 2x. Yes or no? Imagine, can you imagine? Suppose if this pulley will go here, right? So the total change in length of wire will be x this and x this, 2x. So obviously this mass will come by 2x distance down now, right? Can you imagine? Right? Because we have two wires in this pulley. Okay, so if you go by x distance, total length of wire which will move is 2x, right? This one. So if this mass is coming down by x distance, so this will go by x by 2 distance. Yes or no? Tell me, yes or no? Everyone should get, don't worry. We'll solve one problem only, but we'll understand the concept. Okay, everyone got this? So I can say that A1, if A1 is A, then what is A2? Tell me. If A1 is A, then what is A2? Tell me, everyone. If A1 is A, what is A2? Yes, very good. A2 is A by 2 now, right? Because if M1 will go X distance, M2 is going up by X by 2 distance, right? So obviously the acceleration will be in same ratio. Now got it, everyone? Tell me, got it, everyone? Yes or no? Everyone got this? Think about this. Take your time. Take your time. Okay, right? Take your time to try to understand and then find acceleration. Find acceleration, everyone. Find acceleration. Step by step. See, I'm asking you again and again. If there's anyone who didn't get this concept, right? Please ask. Okay, see, close your eyes and just imagine. Listen to me and just imagine. Okay, right? Now, see this. I'm saying that if this pulley, right, and this is a massless pulley, right? It doesn't have any mass. So if this pulley will go up by x distance, just imagine that this pulley is going up by x distance, right? Suppose, right? This pulley will move up by x distance. This is your x distance. Just imagine. This is your x distance, right? Remove this. All of you imagine this. Now, tell me, how much string will unfold? Tell me, how much, what would be the length of string that will unfold if pulley is moving up by x distance? Tell me, just think about this. 2x, agree? Agree, yes or no? Everyone agree? Right? Now if this will unfold, then obviously this, the length of y is constant now. Obviously this should come down, right? The mass m1 will come down, right? Now how much distance it will come down? 2x only. Right, everyone? Understood this? Right? That's what I said. Okay, that's what I said. If m1 is x, then the distance covered by m2 is x by 2. Okay? Got it, everyone? Got it now? Yes? Everyone is getting this concept? Okay, very good. Now try to find the expression now. Try to find the expression. What would be the value of expression? Okay, everyone, I'm giving you 2 minutes. Okay, try to find the value of acceleration. Take 2 minutes, everyone. Okay, so what I did, right? I multiplied this equation by 2. Okay, and then added, I'll just name it as equation 1, equation 2. Okay, okay. M1 is 20 kg. M1 is 20 kg. Okay, M1 is 20 kg. So everyone is clear with this concept? Tell me yes or no. Everyone is clear with this concept? Everyone should be clear with this concept. If you have any doubt, please ask. Okay. Okay, everyone? Right? Okay, so let's solve one more problem. How many of you remember the wedge concept that we studied in last class? All of you remember the wedge concept that we studied last class? Yes or no? Tell me. Just raise your hand. Do you remember the wedge concept? Yes? Okay. So the next problem will involve both. Right? Let's see who can imagine. Let's see who can imagine. Okay, try solving this. Everyone try solving this. Take your time and try solving this. Don't consider that this is a hard problem. It's not hard problem. Okay, you just have to get the basic idea, right? Do whatever you are doing in all the problems. Yes, you need to find A, find expression. Please try solving this. This will be our last problem. After this, we'll have one Kahoot session. Okay. Okay, sorry, I was muted. Thank you, Mohit. So M1 you understood, right? M1 it's easy. M1 we have only two forces. M1G downward direction, tension, upward direction. That is equal to your mass into acceleration. Okay. Now when you talk about M2G, M2. So we have three forces. Yes or no? We have three forces. Agree? We have three forces. One normal, which is perpendicular to the surface. Normal, which is perpendicular to the surface. Tension, which is along the wedge, and then mg, which is in downward direction. So that's what I showed, right? Okay, everyone, tell me, everyone is fine with this? So I guess everyone understood your free body diagram of this one. Okay, now let's go to step 2. Okay, now it's quite easy to write the equation for mass m1. For mass m1 is quite easy. For m1, that is equal to m1g minus, okay, I don't know that if m1 is, m2 is more, right? So I'll just write anything, okay? Wait, I'll just assume that m2 will go down and m1 will go up. So I'll write like this, T minus m1g is equal to m1a1, yes or no, for mass m1. Now for mass m2, now mass m2 is not in one axis, that's a concept, right? That's a concept. So here the axis that we will take is along the wedge and perpendicular to the wedge. How many of you remember right? I hope all of you remember the axis that I will take, the axis which will be better is along the wedge and perpendicular to the wedge. It will be easier, yes or no, right? It will be easier. Now this angle is given as 30 degree. So this angle would be, tell me, right? What is this angle? 60, right? Yes or no? 60. So this M2 will have two components, right? So I can say that M2 will have two components, one in this X direction, one in Y direction. Okay, so let's write for M2, M2 along X axis. This is your X axis, this is your Y axis. X dash, Y dash along X dash axis. Now, what are the forces? Think about this. What are the forces? This is T and mg, as simple as that, right? M2g cos theta. So I can write like this: M2g cos 30 degree, right? In this, sorry, cos 60 degree, no? It is 60 degree, right? So cos 60 degree. Because the component of M2 along x-axis, it is M2 cos theta, na? Yes or no? Tell me, yes or no? The component of M2 along this x-axis will be M2g cos theta. Force into cos theta minus T1 is equal to M2 into A2. Yes or no? Yes or no? And we know that since wire is same, P is also same. Since wire is same, P is also same. Okay. Now, do you need to write the equation along y dash axis? Tell me, do you need to write the force equation in y dash axis? No, because it is not moving in y dash axis, right? So we don't have to worry about that. Okay, the body is sliding now, it is moving along x dash axis, right? Okay, okay then. So that is your second concept, as simple as that. Now tell me, if this M1 will go up by x distance, how much distance it will cover along this direction? Tell me. Same x now, because the length of wire is x only. Yes, very good everyone. So now you are getting the concept. So I can say that if A1 is equal to A, then A2 is also equal to A. Because see, we have wire like this, na? See this, we have wire like this, right? The length of wire is constant. So obviously if this wire will move up to this point, right? If it move up to this point, so this wire should move ahead this point, right everyone? Got it? Agree? Okay, very good everyone. So A1, A2 is A. Now you have to eliminate T, just add equation 1 and 2. 1, 2. Add 1 and 2. Add. Okay, so what you will get? You will get M2g cos theta cos 60 degree minus M1g is equal to M1 plus M2 into A. Yes or no? Tell me, yes or no? So expression is equal to M2 cos 60 degree minus M1 whereby into G. Your answer will be 0. Okay, the body will not move. The answer will be 0. Okay, understood? Why it will be 0? Tell me. Because M2 is 20. Yes or no? M2 is 20 and cos 60 is 1 by 2. So 20 into 1 by 2, 10. 10 minus 10, 0. Yes or no? Yes or no? Got it? Okay. Okay, everyone. So we will end today's class by this problem only. Okay, it is not just 3 problems, it is 3 concepts. Okay, I'll take next class, I'll take half an hour extra. Okay, everyone got this concept, yes or no? What we have studied till today, we studied how to write the force equation and how to use constraint equations. Yes or no? Tell me. Okay, so I'll just share this video again. Please watch this video, okay, and try to understand the concepts. It's not 3 problems, it is actually 3 concepts. Okay, try to think, try to imagine, right? Try to add more pulleys, try to frame your own problems. Then your physics or chemistry, whatever subject you will study, it will be very strong. Try to frame more problems now, right? Everyone try to frame 5 more problems. Add more pulley, change the data, right? Change the variable, give expression, find mass, like that. Okay, agree? Okay, everyone? Okay, so I hope everyone got the concept. Thank you, everyone. Okay, please watch this video again, make your own notes. In next class, we will just solve everyone. Yes, okay. Yes, Ankit. Okay, bye everyone. Thank you, everyone. Okay, bye everyone. We don't have time now, Ankit. Okay, because I'm having another class. Okay, I thought that we get finished by 2:25, 2:20, so I'll just click out, but it took more time. Okay, okay, bye everyone. Next class we'll click out, don't worry. Okay, okay, bye everyone.